We are now looking at some complicated Venn diagrams, hey? All right, you can forgive us. We are math teachers. We are not English teachers, okay? So we're looking at some complicated Venn diagrams. Now, I am assuming, okay, that you guys have been doing Venn diagrams. Can you just let me know, did you do Venn diagrams in the last lesson with Teacher Coco? Yeah? Okay, cool. So we're all good. You started on Venn diagrams, and now we're going to start looking at maybe some more complicated Venn diagrams. Notice Teacher Coco and I never use the word hard. Do you see it? Because maths is not hard. These are just more complicated. All right. Let's make the screen a little bit bigger for you. Okay. So in a roadblock, 102 cars were checked for roadworthiness. So already I would be going, and if it was me, and I'm sure Teacher Coco also told you this, I would take my highlighter out and I'm going to go highlight some important information that I need here. Okay? So in a roadblock, 102 cars were checked for roadworthiness. All right. 34 cars passed and the rest failed. Okay, so 34 cars passed. Another important piece of information. Okay. And the rest failed because of defective brakes, lights, or tires. So guys, we've got 3 different ways that people can fail according to the roadworthiness of their car. So roadworthiness, the ability to drive it, if it's okay on the road, that kind of thing. Okay. 30 had faulty brakes. Cool. 30 had smooth tires. All right. And 33 had faulty lights. Cool. All right. This is where we start getting a little bit, okay, so let's go see. 7 failed on both lights and tires. Okay, so 7 are going to fail on both lights and on tires. All right. 10 failed on both lights and brakes. So 10 failed on both lights and brakes. And finally, 11 failed on both brakes and tires. Okay. Note, there are 3 events to consider. Faulty lights, smooth tires, okay, and faulty brakes. So we've got 3 events that we need to consider here, all right? And we need to have a look at of how many circles we need. If we've got 3 events, what do we need to have? We need to have 3 circles in our diagram. So I'm going to go ahead here and erase this markings that I had here before, all right? Because here, Teacher Coco has put the start of this Venn diagram in here for us. So there is one small mistake. In a roadblock, 102 cars were checked. So this needs to be your total sample size is 102. So you would have a block, right? You know you've got 3 events. You would have your 3 circles. And your total sample size, your NS, total sample size, is equal to 102. Where did I get the 102? 102 cars were actually inside of the roadblock. Right. Then we know that 34 cars passed. So of the 3 different events, the 3 different ways that you could fail this test, okay, or fail or get stopped, or whatever it is, okay, there's 34 cars that didn't get stopped. So 34 is going to appear where? 34 is going to appear out here, hey? So here's 34. Teacher Coco has put it there for you guys. 34. Now, I know I need to have L for lights. I know I need to have B for brakes, and I know I need to have T, all right, for smooth tires. Okay, so L is equal to 33. Where do those 33 come from? We're going to move up here again. Okay, so L, 33 had faulty lights. 30 had faulty brakes, and 30 have smooth tires. Right. Now, some of these intersect with each other, and let's see how that's going to work. So do you notice how Teacher Coco, she hasn't put the numbers inside the circles. She's put the numbers on the outside of the circles, because the total of that B circle needs to come to 30. The total of that L circle needs to come to 33. And the total of the T circle needs to come to 30 as well. 7 failed on both lights and tires. So lights and tires, there's lights, there's tires. What do we know? We know that where lights and tires are intersecting, so this part here, right, where they're overlapping, that total part is going to be equal to 7 here. So I'm going to go right here. Lights plus tires equals 7. All right. 10 failed on both lights and brakes. So lights plus brakes equals 10 here. So here's lights, and here's brakes, and those two need to come up to 10. And finally, 11 failed on both brakes and tires. That comes up to 11. So here is brakes and tires. And when I add those two up, it needs to come up to 11. Now, guys, there's a line missing from this. There's a line missing. Who can tell me what's missing from our information they've given me? What's missing? Who knows? Anyone know what's missing here? Can we actually finish this off? Can we finish this Venn diagram up off? Have they given us enough information? What's missing? We know what lights and tires are. We know what lights and brakes are. We know what brakes and tires are, but what's missing? What's missing is this very important block in the middle. Okay, so what's missing is that very important block in the middle. And I'm going to go ahead and I'm going to give you an example of what it would say. All right. It could say it in a variety of different ways, but for this example, we're going to go say 4 cars were impounded as all elements, oh, I'm running out of space, were faulty. Okay, so in other words, 4 of the cars, okay, were just impounded. They were just like, we're taking them away, we're driving them off. Why? Because everything is just faulty on them. They don't have lights, they don't have brakes, and they don't have tires. All right, so 4 are just completely wrong. Okay, there is other ways to calculate this. All right, you mainly look at it in grade 11. So in grade 10, they normally give it to you. Okay, so here we go, 4 in the center. That's where they're all coming together. Right, let's go do the first block. So lights and tires, this first one. What does it need to add up to? It needs to add up to 7. I already have 4 in the center, guys. So what's going to go in this little block here? 3 plus what's going to give me 7? Amandla, how do we know it's 4 cars? We don't. They didn't tell us. They didn't give it to us. So I'm giving you that line because they will normally give you that line. Okay. There is a calculation where you can go and calculate it, and we will do it afterwards, but I'm giving you 4 for now. Okay. I hope that makes sense. All right. So to get 7 in this blue band here, lights plus tires equals 7. So already I've got 4. So what's going to be here? It's going to be 3. Okay. And now, oh, I love Venn diagrams because it's like doing a puzzle. The whole L circle has to add up to 33. I already have 3 plus 4, which gives me 7. So what needs to be left over in just the lights block, guys? What am I going to say? I'm going to say 33 minus 3 minus 4 is going to give me 26. Okay. Let's go work out lights and brakes. So that was this red band over here, lights plus brakes. Right. Oh, am I wrong? Yes, Christy, you are wrong. Apologies, guys. Lights plus brakes was the green band. So there they are overlapping, lights and brakes. Lights and brakes needs to add up to 10. Okay. Lights and brakes needs to add up to 10. We already know that lights plus brakes plus tires gives me 4. So how am I going to work out what's left in this little green bits? What's it going to be? 4 plus what gives me 10?
Plus
Nice.
6.
Thank you. Oh, it's so nice to hear voices as well. Thank you. 6. Cool. All right. Can I calculate? Oh, guys, I've made a fatal error. Apologies. Am I right in saying that this now can't be 26? Am I right? Because 3 plus 4 plus 6 plus 26 doesn't work out, hey? So what is this one going to be now? It's going to be 3 plus 4 is 7. Plus 6 is, whew, it's been a long day, 13. And 33 minus 13 is going to give me 20. Do you see that my whole circle is now complete, hey? Let's go this side. Let's do this last little bit here. Okay. Brakes plus tires gives me 11. Brakes plus tires gives me 11. I've already got 4. So 4 plus what will give me 11? 4 plus 7. Can I finish everything off now, guys? Can I finish off the circles? So for my brakes circle, it needs to add up to 30. 6 plus 4 is 10. Plus 7 is 17. 30 minus 17 is going to give me 13. Right, last one. 3 plus 4 is 7. Plus another 7 is 14. 30 minus 14 gives me 16. Is my Venn diagram now complete? Yes, my Venn diagram is now complete. Okay, you can screenshot that. Okay, grade 10s, remember, we always love you to screenshot. All right, you can screenshot that or you can draw it quickly. If you're busy drawing, I'll give you a few minutes. Okay. All right, will you guys just give me a sign if you're ready to move on? A thumbs up or a yes in the notes. Okay, cool. I've got 1 so far, 2, 3, 4. All right, so we're ready to move on to the next question. Okay, well done, guys. Thanks. Okay, so we're going back over this, and I just want to make sure that I am in Teacher Kat's correct lesson. Yes, we are. Okay, and Teacher Coco, sorry. So we're looking at union, intersection, and mutually exclusive events tonight. So when we're looking at our 3 different circles, that's what we're looking at, where they're coming to a union, whether they're intersecting, or whether we have some mutually exclusive events. Let's have a look. This little diagram that's drawn up here is super important. I'm sure Teacher Coco went over it with you before, but my suggestion is, guys, go take a screenshot. Okay, it's really important. You're going to see it again and again and again. Go take a screenshot. Okay. All right. So when I have A and I have that like little door, I call it a door, okay, like an archway, right? And B, it means that it's saying A and B. And what that means is it's looking for the intersection of A and B, so where they overlap, all right? In other words, the elements in both sets, A and B. And I always like to say, if I'm looking for A and B, I can go draw my archway underneath those two. It's a door frame, it's an archway, it's narrow, it's that little piece in the middle. If I'm looking for A or B, all right, it means that I'm looking for everything that's falling inside. So everything. So if I'm thinking of trying to catch everything, right, the way that I remember it is if I'm looking to try catch everything, I want to go and I want to put a basket. Right. A or B, it's everything. A or B, it doesn't really matter. Okay. I want everything, in other words. So I'm going to put a basket underneath it because I want to see everything. That basket's going to be nice and wide. Can you see how I'm trying to get the connections in your mind here? And if I've got an A dash, what does that mean? Okay. That means not A. So in other words, I'm looking for everything that's not A. All right. And in this case, we can see not A is going to be this entire circle. And of course, it's going to include the overlap. Okay. All right. So let's have a look at what that looks like in questions. All right. I'm hoping you can all see this. For some reason, it's overlapped a little bit. Let's try to take that out for you. Okay. So at 12-sided, and I bet you never thought you'd hear this word again. You probably did it in grade 8 or grade 9, a dodecahedral. Okay, so dodecahedral just means like it's a 12-sided die, all right, is rolled. So it's a die, okay, picture a die, and this die, instead of having 6 sides, it's got 12 sides, all right. The following events are defined. So in my dodecahedral, okay, I roll my dodecahedral, and they're classifying 3 different events that we're looking for here. The first event, we're looking for multiples of 3. Right. The first event, we're looking for multiples of 3. So in the first question, they're asking me to go and to list the outcomes in a set form. So let's go draw them next to this here for you. All right. So if I'm looking to list the outcomes in a set form, well then A is going to be equal to, I'm looking for the multiples of 3 that would appear on a dodecahedral, hey? So dodecahedral has 3 sides, so I've got 3, 6, 9, 12. How do I know I'm only going up to 12? Because there's only 12 sides. All right. B is looking for the factors of 9. So if I'm looking for the factors of 9, B, okay? Factors, not multiples, so be careful. Factors this time. So what numbers go into 9? What factors are 9? So 1, 3, and 9. And finally, for C, they're wanting the multiples of 5. So if they're wanting the multiples of 5, I'm going to have 5 and 10. Okay. So A is done. Tick, finish. B, draw a Venn diagram to represent these events. And teacher Croker has put one there next to it, but that only has 2 events. She's wanting you to draw a Venn diagram to represent these events. Guys, I'm going to give you 2 minutes to go try it. 2 minutes. Go give it a try. Okay, give it a try. 2 minutes. All right, you've got about 30 seconds left. All right, so draw a Venn diagram to represent these events. Guys, how many events have we got? We've got 1, 2, 3. So this lovely one that teacher Coco has given us here, not really going to help us here because there's only 2 events in here. I'm going to go and I'm going to take teacher Coco's drawing and I'm going to use it still. All right, because I know I'm going to need a Venn diagram. I'm just going to take that line away and I'm going to extend my box a little bit. All right. Now I'm going to go have a look. Okay. So, first of all, how many events or how many sides do we have in total? We have 12, hey? So in total, there are 12 sides. Amandla, do you want to ask me your question? Amandla? No? Okay. So my total sample size equals 12. Okay. Amandla, I see your hands up. You're more than welcome. Do you want to help me answer it? Is that what you're asking me? Okay. Maybe it was just an accident. So my total sample size is 12. Now, if I go back and I look at the events that I've got, A has 3, 6, 9, 12. B has 1, 3, 9. And C has 5 and 10. No problem, Amanda. No problem. All right. So I want to see, do these events actually intersect? So here in A, I see that there's a 3. And here in B, I see there's a 3. So yes, we've definitely got an intersection going on. I see a 6 in A, no 6s in B, no 6s in C. I see a 9 in A, and what do you know? There is a 9 in B. And finally, for C, I've got 5 and 10. Does anything come to mind there with 5 and 10? Nope, nothing matches, hey? So if I'm looking, guys, at this, all right, if I'm looking at this, it means that the number of outcomes for A is equal to what? I've got 1, 2, 3, 4 outcomes here, hey? The number of outcomes, the number of outcomes for B, how many outcomes do I have? 1, 2, 3. And the number of outcomes for C are 2. So in total, my sample size is 12, right? The number of outcomes for A is 4. The number of outcomes for B is 3. And the number of outcomes for C is 2. Now, do you agree with me? There's some numbers that we're not even using. So on the dodecahedron, I would have the number 1. So I see the number 1. That's cool. Then I would have the number 2. Guys, is the number 2 being used anywhere here? Nope. Okay. So let's go call that the number of Z. None. 0. All right. So first of all, 1, I saw 2. Then I've got 3. Cool. What about 4? Is 4 being used? Nope. 4. Then I've got 5. Yes. I've got 6. Yes. Have I got 7? Nope, so 7. Have I got 8? Nope, so 8. Then I've got 9, then I've got 10, and what's the last number that's not being used? 11. So the number of not being used, the number of the ones that we're not using equals 11. That's my favorite part of, sorry, not 11. Guys, I'm so sorry. I said 11 in my brain. Correct me. I'm just testing you. How many do we count to? We counted to 5, hey? Let's confirm once more. We're not using 1, we're not using 2, we're not using 4, we're not using 7, and we're not using 11. Guys, happy with that? Thumbs up, anyone? Awesome. Okay, so we're not using 5 of the outcomes. If we're not using 5 of the outcomes at all, where they're going to be? They're going to be sitting out here. 5 of the outcomes are going to be sitting out there. Okay, ma'am, we are using 1. You are right, we are using 1. Oh my goodness, you see, I was just testing you. So we're using 1. Okay, let's go again. 1 we're using, 2 we're not using, 3 we're using, 4 we're not using, 5 we're using, 6 we're using, 7 we're not using, 8 we're not using, and 11 we're not using. So it definitely was 5. Apologies. Okay. Right. Now, we saw that our pink highlighter told us that there was some overlap. So literally, here's my pink highlighter, is it not? That's my pink highlighter part. Okay, that's my pink highlighter part. All right. For my pink highlighter part, right? How many numbers are overlapping? 3's overlapping and 9's overlapping. So what needs to be in the center here? I need to have 2. Right. I'm going to call this circle A. I'm going to call this circle B. So at the moment, I'm focused on the ones that are overlapping, guys. So in total, the number of outcomes for A is 4. So in this whole block, I've already got 2 overlapping. So how many need to be in the rest of the circle? 2 plus what add up to 4? 2 plus 2, hey? Okay, let's look at B. The number of outcomes for B in total needs to be 3. I've already got 2 in the block. So what needs to be here? 1. Good. Let's do C now. Is C overlapping? Is C overlapping? Is he going anywhere, C? Is he matched up with this A and B at all? Nope. So where are we going to draw him? We're going to draw him in his own little island here, so that he's not touching anything. His own little island. We're going to call him C. And what did we know about C? C had 2 outcomes. Let's add up all the numbers. 2 plus 2 is 4, plus 1 is 5, plus 2 is 7, plus the 5 on the outside. Does that give us 12? Total sample size of 12? Yes, it does. Right, let's finish it off. They want to know, what will the probability of A be? What's the probability of A? Right. How many numbers are in A? We had 4 over. How many sides in total there are? 12. Can we simplify that? Yes, we can. We can make it 1 over 3. Do we have to simplify it? No, it's probability, but it is always good practice to simplify your fractions. Let's do the probability of B. B is 3 over 12. Can we simplify that? Yes, we can. 1 over 4. And finally, let's do the probability of C. Probability of C is 2 over 12, which is 1 over 6. Okay. I'm going to put it all on one page for you. So if you want to take a screenshot, you can. All right. Does anyone have any questions about this one before we move on? Good, cool. No one's got questions? All right, it's a bit confusing with the thumbs up and the thumbs down, but great. Awesome, guys. I'm glad you don't have any questions yet. Maybe you'll still have some when we're carrying on. Okay. Right. Consider the following Venn diagram or the given Venn diagram. Right. So I'm just going to go through it with you quickly. There's a block. The S is on the outside. Who knows what the S stands for, please? What is the S? What's the S representing, guys? What does that S represent? Who knows?
Sample size.
Thank you. Well done. Thank you, guys. So S stands for the sample size. So the total sample size of everything that we're doing here, the total sample size of everything that we are doing. Okay. Now, what stands for, sorry, okay, so S, perfect. Okay, so it says, consider the following Venn diagram. Write down the sets A, B, and C. So they want us to write down the sets for A, B, and C. Let's go. I'm going to try and make some space on this side. Set for A, S, B, C. Let's go see the letters that are appearing here. I've got A, B, C, D, E, F, G, H, I, J, K, L, N. All right. So let's start with A because that's a little bit easier, hey? So in A, I've got A, B, C, D, and E. Let's go to B. In B, I've got D, E, F, G, H, and I. In C, I've got J. Oopsie. I've got J and I've got K. Hey? And the total sample, what have I got? I have A, B, C, D, E, F, G, H, I, J, and K. Right, that's us writing down our sets. The next question says, write down the N of A, the N of B, and the N of C. What does the N stand for? It stands for the number of. So it's got a very fancy way as well, but I always say the number of. So if I've got the N of A, well, I just went and wrote down my sample set, but that's on the other side of my page. So I'm going to go here. In A, I've got 1, 2, 3, 4, 5 numbers that appear. In B, I've got 1, 2, 3, 4, 5, 6 numbers that are appearing. And my N of C is going to be 2 numbers that are appearing. Guys, now that I know what my N's are and I know what my total sample size is, how do I know what my total sample size is? Because here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There was my total sample size. And I'm just going to, I know it didn't ask for it, but I'm going to go say N of S equals 11 up here. Can I calculate my probabilities? Can I calculate my probabilities? I left some letters off. I'm so sorry. Let's just go again. A, B, C, D, E, F, G, H, I, J, K, L, M. Apologies, it's 13. Let's go back here. J, K, L, M. Apologies, I left the ones on the outside out. Okay, you go do the probabilities for me. All right, you've got the total. You've got the number in each. Go calculate the probability. So probability of A equals 5 over 11. Probability, not 11, sorry guys, 13. What am I saying? Probability of B is equal to 6 over 13. And probability of C is equal to 2 over 13. Now it says, redraw the Venn diagram showing the probabilities. Redraw the Venn diagram showing the probabilities. So I'm going to go in mine and I'm going to be a little bit sneaky. Oopsie. Okay, I'm going to go color all of these ones in a different color here. So let's just make sure. No. Oh, I didn't see letter N. Oh my gosh. Grade 11, grade 10s, can you see? It's been a long day. You're absolutely right. I didn't see N on the side there. 14. Let's go back. Apologies. I didn't see N. Right, I would have got marks taken off. 14. 14 and 2 over 14. So that one's fine. This one we can make 3 over 7. This one we can make 1 over 7. Thank you. Right. Can you go draw it with the probabilities for me? Can you go draw this Venn diagram using the probabilities? Go try it out. Okay. My pen does not want to work properly with me tonight. Okay, go redraw it. All right, here we go. Drawing the Venn diagram using the probabilities. How are we going to do that? Well, we know where A and B are overlapping, it's only going to be 2 over 7, hey? So A and B are overlapping, 2 over 7. Which means that the probability, again, Kirsty, apologies, guys. Not 2 over 7, 1 over 7. And I'm going to redraw this so it's nice and big for you so you can see as well. Let's go. I'm going to go the side. Okay, let's go redraw. All right, I'm redrawing. I'm drawing it over here for you. So here's my drawing, nice and big. Here's my 2 circles that were overlapping, A and B. Okay. We know we've got good old C here on the corner. All right. According to my drawing, there was 2 over 14. So 2 over 14, which is the same as saying 1 over 7. So in the center, I'm seeing 1 over 7. In total for A block, what's the probability need to be? It needs to be 3 over 7, hey? So the probability of A happening is 3 over 7. I've already got 1 over 7. So what have I got left to get? I've got 2 over 7. The probability of B was equal to 3 over 7. So if that whole circle needs to be 3 over 7, and I've already got 1 over 7, this also needs to be 2/7. I just want to come back here, guys, and just check. 1, 2, 3. I've already made another mistake. Oh my goodness. Guys are going to tell teacher cat on me. Okay, the probability of A was 5/7. Apologies. This is 5/14. This was 3/7. And this was 1/7. 1/7. Okay. So 5/14, we already had 2/14, so this is going to be 3/14. 1/7, so this is going to be 1/7. How many were left out of the block? There was that one sneaky one that was hiding. Left out of the block was 3/14. And the probability of having the whole sample is going to be 1. Now, can you show that as a percentage? Yeah, you could work them out in percentages. You're going to press equals on your calculator, okay, and you're going to get it until it gets into a percentage, and you times about 100. You could have it as percentages. Could you show it as a decimal? Yeah, you could do it as a decimal. What's the easiest thing to do? To show it as a fraction. All right. Are we good with all my mistakes? Are we good? Good. Nice. Cool. Well done, guys. All right. Let's get into more practice of actually drawing these Venn diagrams. I'm going to see if Teacher Cat, Teacher Cat gave us another Venn one. All right. In a survey conducted at a music store in Joburg, it was found that 120 people bought only trance music, 150 people bought only deep house music, and 100 people bought both. 20 people did not buy either trance or deep house music. Let T equal trance music and D equal deep house music. Number 1, draw a Venn diagram. Right, I'm giving you 2 minutes to go have a look at a Venn diagram. How many events do I have? I have 2. So it's a nice Venn diagram, this one. Go and have a look. 2 minutes. Got 1 more minute left. All right, let's give it a look. So, draw a Venn diagram to represent events T and D. We know that there's an overlap. Why is there an overlap? Because 100 people bought both. That's telling you there's an overlap here. So here is my drawing. Okay. I'm going to have T. Right? And I'm going to have D, they told me. All right. In a survey conducted, it was found. So did they give us the total sample size? No. So we keep going. I like to start with the stuff in the middle. So the both. They say 100 people bought both. So let's go. In the center, what am I going to have? I'm going to have 100. It was found that 120 people bought only trance music. So that means that for trance music, for the only trance music parts, it's 120. And 100 people, 150 people bought only deep house music. So here, 150. 20 people did not buy either. So on the outside, we have 20. Okay. So if I go add up my total sample size, 120 plus 100 gives me 220, plus 150 gives me 370, plus the 20, do you all agree it comes to 390 people that they surveyed? Awesome. Let's go look at my questions. Determine the N of T, the N of D, and the N of S. Well, we already know if I'm looking for the, and I'm going to do it in red, the N of T, it means I must be looking at the circle that's in red. So the N of T is going to be equal to 220. Are we happy? Awesome. Now I'm looking for the N of D. I'm going to do it in green. So my N of D is going to be equal to 250. It's 100 plus 150, 250. And finally, my N of S, let's just go show the workings for it. I took 120 plus 100 plus 150 plus 20, and that gave me 390. Okay. Number 3. Calculate the probability of selecting at random a person who likes only deep house music. All right, a person who likes only deep house music. So in other words, the probability of only deep house music, okay, the probability of only deep house music, we know that 150 people only liked deep house music over a total of 390. Could we simplify that? We could. 15 over 39. Do we have to simplify it? Not really. Could we simplify it further? Put on your calculators for me. See if we can simplify it further. I think we can. I'm doing it in my head, but I definitely think we can simplify that further. What do we get, guys? What's the simplest fraction here? 150 over 390. What's the simplest fraction we can do?
5 over 13.
Thank you. 5 over 13. So nice to hear these voices out of the dark. Thank you. Okay. Calculate the probability of selecting at random a person who likes only trance music. So P of only T. All right. We saw that. What was the P of only T? It was 120 over 390. Put that on your calculator for me, please. Do we get 4 over 13? Thank you. Calculate the probability of selecting at random a person who likes neither types of music. So what was neither types of music? P of neither, let's call it. The P of neither was 20 over 390, which is 2 over 39. And finally, calculate the probability of selecting at random a person who likes both types of music. Both types of music was 100. So probability, let's write it out nicely for you. Okay, so probability of both T and D. Probability of T. And what's the fancy way of saying that? Who knows? Is it fair to say that if I'm looking for both T, what am I going to say? T and D. Remember what's and? It's the door frame, hey? Probability of P and D, it's that little bit, the door frame. And the probability of T and D is equal to 100 over 390, which is equal to 10 over 39. Okay, nice. Well done. Let me make it smaller for you in case you want to take a screenshot. Oh, it's a very tiny screenshot. Sorry, guys. There we go. Okay, hopefully you've got it. Let's move on to our next one. In a recent survey, it was found that 90 people supported Kaizer Chiefs only. 80 people supported Orlando Pirates only. 5 people supported both teams. There were 10 people who did not support either team. So I've got the Chiefs, I've got the Pirates, and I know that sitting on the outside here, I've got 5, hey? Oh, I'm lying to you. I've got 10. 10 supported none. Right. 5 people supported both teams. Where's that 5 going to go? That 5's going to go in the middle. Right. 80 people support 90 people support Kaizer Chiefs only. So 90. 80 people support Orlando Pirates only. So 80. So what's my total S on the outside here? S is going to be equal to 90 plus 5 plus 80 plus 10. Do you agree it gives me 185? Awesome. Right. Determine the probability that a person selected at random will support the Chiefs only. Supporting the Chiefs only. So, probability of the Chiefs only. Probability of the Chiefs only, guys. Let's make this a bit bigger for ourselves first. Right, the probability of the Chiefs only is going to give me 90 over, what was my total? 185. Good. Could I make that smaller?
Yes, ma'am.
What is it going to be? Tell me.
18 over 37.
18 over 37. Thank you so much. Right. Determine the probability that a person selected at random, okay, determine the probability that a person selected at random will support both teams. Both teams was 5. So probability, and what did we say? C and P, or you can write with the little door frame, either one. Probability of C and P is going to be 5 over 185. 5 over 185 gives me 1 over 37. Nice. Determine that a probability that a person selected at random will support none of the teams. Probability of none is going to give me 10 over 185. 10 over 185 is going to give me 2. over 37. All right. Determine whether the events involved are inclusive or mutually exclusive. Are they inclusive or mutually exclusive? Okay. Anyone want to offer an answer there? All right. Let's talk about it. Okay. So, if events are inclusive, it means that you can be a Pirates fan and a Chiefs fan. Okay, so you have some overlap. So when you have overlap, that means what? It means that it's going to be inclusive. You can be a fan of the Pirates and be a fan of the Chiefs, right? If the events were mutually exclusive, right? If they were exclusive, it means there would be no overlap. Either you like the Pirates or you like the Chiefs. There's no overlap in between. All right. Finally, okay, are these events complementary? Okay, and give a reason. What do you guys think? Are they complementary? And give a reason. Well, what does complementary mean? Complementary events are when two events, okay, when you add them together, if one event's occurrence means that the other one cannot occur, okay? In other words, their probabilities add up to 1. All right. So in other words, okay, the occurrence, if one event's occurrence means the other cannot occur. All right. So in this case, supporting the Kaiser Chiefs and supporting the Orlando Pirates, they're not complementary. Okay? Because a person can support both teams. So because you can support both teams, the events are not complementary. Person can support both teams.